Hello everyone. Welcome to your physics class of class 6th. I hope you all will be fine. Students, in my previous video I explained you lesson number 4 and the topic was lever. So now today in this video we will continue our lesson and also I will give you the question answers of lesson number 4. Okay, so let's begin our class. First, we will discuss about pulley. What is a pulley? A pulley is a simple machine by which the direction of effort is changed to raise up a load. Means by using a pulley, it is a simple machine by which the direction of effort, means the effort that we applies on that machine is changed, that direction of that effort is changed to raise up a load. Means when you want to raise up a load, either it can be a bucket full of water from a well, a heavy material in a factory, or a car engine in a garage. We can lift all these loads by using a pulley by applying the effort in downward direction. Means suppose if you want to take out a bucket full of water from the well, so if without a pulley you want to take out this bucket of water, you have to pull this bucket in the upward direction. Means you have to apply the force in the upward direction. With the help of this rope you can take out the water from the well. But if you use a pulley, so by using a pulley we have to apply the force in the downward direction. Suppose from this side this the load is attached, means the bucket that we are taking out from the well is attached, so we have to apply the force in the downward direction with the help of this string. Okay, so with the help of a pulley, we can take out and we can raise up a load by changing the direction of effort. Okay, so a pulley is consist of a circular disc made of a metal or wood. This pulley is made up of a circular disc. You can see here this is a circular disc. It can be either of metal or wood. The disc can rotate about an axle passing through its center. This is an axle. The disc has a groove along its rim. Means along its rim there is a groove, and through that groove only the string or a rope can pass around. And the ends of the axle are supported on a frame which is called a block. This is a block. Okay, and it is attached to a fixed support. Okay, so this is an arrangement of a pulley. Now, to raise a load, the load is attached to one end of the string. Suppose the bucket that we are taking out from a well is attached here, and the effort, means the force that we apply on this string, that is known as effort. So effort is applied at the other end by pulling it in the downward direction. Okay, we can raise the load. Now mechanical advantage of the pulley. In an ideal pulley, the effort applied is equal to the load to be lifted. That is, effort is equals to load. So the mechanical advantage for pulley is 1. In an actual pulley, due to friction, the mechanical advantage is less than 1. That is, effort is more than the load. Okay. Now the reason why we use a pulley when its mechanical advantage is equal to 1 or less than 1 is that pulley allows us to apply the effort downwards, that is in a convenient direction, because to raise a load directly upwards is difficult, but with the help of a pulley the effort can be applied in the downward direction to move the load upward, and that's why we use pulley even though its mechanical advantage is equal to 1 or less than 1. One can hang on it to make use of its own weight also in order to apply the effort. Okay. Now wheel and axle. A wheel and axle is also a simple machine. It consists of either a wheel attached to an axle or two wheels of different diameters attached together, as you can see here in this figure. Okay, the wheel is a circular object. Wheel is a circular object which is capable of rotating on its own axis. This is a axis, suppose, and so wheel is a circular object which is capable of rotating on its own axis. As the wheel rotates, the axle also rotates with it and advances linearly, and it moves linearly. Okay, if there are two wheels, the effort is applied on the bigger wheel and the load is attached with the smaller wheel called the axle. Okay, so this is wheel and axle. Now the use of wheel and axle provides the linear motion you can by the rotation of wheel, and so it reduces the friction because rolling friction is less than the sliding friction. Examples of wheel and axle are steering wheel of a car, bicycle pedal, doorknob, screwdriver, water tap. These are some examples of wheel and axle. Okay. Now inclined plane. An inclined plane is a slanting wooden plank or a sloping surface. You can see here this is an inclined plane. It is a simple machine which is used to move a load up with a less effort. Okay, we use inclined plane as a simple machine because it helps us to move a load up with a less effort. The effort required to push a load up an inclined plane is less than the load, means the effort that is required to push a load up on an inclined plane is less than the load. Thus, the mechanical advantage of an inclined plane is always greater than 1. Okay. For the greater mechanical advantage, the length of the slope AB must be much more than its vertical height. Means this sloping side of this inclined plane must be greater than this height. Okay. In other words, so smaller the slope means the smaller the slope, more is the mechanical advantage. That is, less effort is needed to push up the load. Okay. A pulley while loading examples are a pulley while loading a heavy drum on a truck use a wooden plank. This is an example a an inclined plane. Means a pulley while loading a heavy drum on a truck use a wooden plank. Okay. A ramp or an inclined plane provided in a building which helps people keeping their scooters, motorcycles, bicycle inside the building by pushing it along the ramp. Hospitals and huge buildings are provided with ramps which help nurses to move up the patient, staircases in our homes, and the road on a hill. These are the examples of inclined plane. Now next is wedge. Now what is a wedge? A wedge is also a simple machine having two sharp edges which is formed by putting two inclined planes together. This is known as wedge. These are the two inclined plane, one on this side and the other on the other side. Okay, when these two are joined together, that is known as a wedge. This is a figure of wedge. This is a sharp end which is made by joining the two inclined plane, this inclined plane and the backside inclined plane. Okay, so this is a wedge and it is used to split a log of wood or any other. Thicker the wedge, easier it is to drive the wedge into the log and split it into pieces. Okay. Examples of wedge: knife, axe, plug, this nail, saw, needle. These are the examples of wedge. Okay. Now screw. A screw is a simple machine which appears like an inclined plane. This you can see here. Here you can see the thread like inclined planes here. So a screw is a simple machine which appears like an inclined plane wound around a rod with a pointed tip. Okay, this is a pointed tip. These are the inclined planes, this which is wound around a this iron nail. Okay, and this is the head of the screw wound around a rod with a pointed tip. Hence, it appears like a nail with grooves on its circular curved surface. This is an example of a screw. Okay, so a screw is made by cutting the spiral. You can see here the spiral grooves on the surface of a metal rod. The spiral grooves so formed are called the threads of the screw. These are known as these spiral grooves are known which is inclined on this iron rod is known as the thread of the screw. Okay, one end of the rod is made narrow. Here you can see this end is narrow pointed, which is called the tip of the screw, and the other is made flat, which is called the head of the screw. A narrow slit is made in the head of the screw so as to turn the screw with the help of a screwdriver. You can see here this is the head of the screw. Here a slit is there with the help of which we can turn the screw with the help of a screwdriver. It is difficult to drive a screw into the wood by hammering it on its head as we do in case of a nail, but it can easily be driven into the wood by turning it with a screwdriver, because the screw then works like an inclined plane, and thus the screw is simply a modified form of an inclined plane. Okay, this is about screw. Now, care of machines. We all use several kinds of machine in our daily life, but we need to take care of the machines. So, for their proper functioning. So, what are the following precautions that we must take are: we should keep the machines clean and free from dust. Second, if the parts of the machine are made of iron, they can rust. So, prevent them from rusting, such parts must be painted. And the third one is friction causes wear and tear of the moving parts of a machine. To reduce friction, these parts must be properly lubricated from time to time. So these are some measures which we have to take care of the machines. Okay. Now lesson number 4 is completed, means explanation is completed. Now we will do the question answers. Okay. First question is, when is work said to be done by a force? Answer: work is said to be done when a force moves an object through a distance on it in its own direction. Okay. Now question number 2, what is energy? And the capacity or the ability to do work is called energy. Question number 3, what do you understand by a machine? A machine is a device that allows us to do work with less effort. Machines make our work easier to do, and have made our lives comfortable and faster. Okay, answer number third. Now, question number 4, what is the principle on which a machine works? So, the principle on which a machine works is the work output of a machine is equals to the work input. Question number 5, state two functions of a machine. So various functions of that a machine can perform are, you can write any two from here. Okay, so you can take the screenshot of these answers and then you can complete your work. Okay, now question number 6, name 6 simple machines. Give an example of each machine. So 6 simple machines are lever, inclined plane, wedge, screw, wheel and axle, and pulley. And these are the examples. You can write any 2 examples of each simple machine. Question number 7. Define the term work input and work output in relation to a machine. So work input is a work done on a machine, and work output is a work that is done by a machine. Okay, now question number 8. Explain the term mechanical advantage of a machine. The mechanical advantage of a machine is the ratio of the load to the effort. In other words, mechanical advantage is equals to load upon effort. Question number 9. Define the term efficiency of a machine. The ratio of the work done by the machine to the work done on the machine is called the efficiency of a machine. This is the, okay, efficiency is equals to output energy upon input energy. Question number 10. What is an ideal machine? A machine in which no part of work done on the machine is wasted is called an ideal machine or a perfect machine. For an ideal machine, work output is equal to the work input, that is efficiency of an ideal machine is 1 or 100%. Question number 11. How can a machine have an efficiency of 100%? Give a reason to support your answer. Efficiency of a machine is always less than 100% as output energy is always less than the input energy, because some energy is lost to overcome friction. Question number 12. A machine is 75% efficient. What do you understand by this statement? If a machine is 75% efficient, it means that 75% of the work input to the machine is obtained as a useful work output. The remaining 25% of work input has been lost in overcoming the friction. Question number 13. What is a lever? A lever is a simple rigid bar which is free to move around a point called fulcrum. Question number 14. Describe 3 orders of lever. Give an example of each and draw a neat diagram showing the position of fulcrum, load and effort in each kind of lever. So the levers are of 3 kinds. Class 1 lever, in which fulcrum is in between the load and the effort. Here is the example of seesaw. You can make any other diagram also of any other example. Okay, class 2 lever has which have load in between the fulcrum and the effort. Example, nutcracker. You can make other diagram also. Some other example. and class 3 lever which has effort in between the fulcrum and the load. Example, forceps. In this case also you can make any you can write any other example also, and diagram also you can make from the book, any other diagram if you want. Now question number 15, what do you mean by the term mechanical advantage of a lever? The mechanical advantage of a lever is equal to the ratio of the effort arm to the load arm. This is called the principle of lever. Which class of lever has mechanical advantage? Always more than one. Give an example. So the mechanical advantage of class 2 lever is always more than one. Example, nutcracker, wheelbarrow, bottle opener, etc. Question number 17. Which class of lever has a mechanical advantage always less than one? Give an example. So class third lever is always is the mechanical advantage of class third lever is always less than one. Example, a pair of tongs, sugar tongs, knife, forceps, etc. Now question number 18. Give an example of class 1 lever in each case where the mechanical advantage is more than 1, equal to 1 and less than 1. So for more than 1, load arm of pliers equal to 1, seesaw, and less than 1, the load arm of a pair of scissors. Okay, now question number 19, name the class of to which the following levers belong. Okay, so these are the class to which all these levers belong. You can write from here. Okay, now question number 20, the diagram given below shows the three kinds of levers. Name that class of each lever and give one example of each class. So these are the diagrams of the levers. So first one is of class 1 lever because fulcrum is in between. Examples, the class 1 levers are seesaw, pair of scissors. These are the examples of class 1 lever. Second is of class 2 lever where load is in between. You can see here load is in this one. First one is class this one is second class 2 lever, and where fulcrum is in between, this is class 1 lever, and where effort is in between, this is class third lever. Okay, so here are the diagrams and the examples you can write from here. Now question number 21, draw a diagram to illustrate the position of fulcrum, load and effort in each of the following: seesaw, beam balance, nutcracker, and a pair of forceps. So you can draw the diagrams from the book, or you can draw from here also. Okay, so these are the diagrams of question number 21. Now question number 22, how can you increase the mechanical advantage of a lever? The mechanical advantage of a lever can be increased by increasing the effort arm or reducing the load arm. Okay. Now question number 23, how does the friction of at the fulcrum affect the mechanical advantage of a lever? Friction at the fulcrum reduces the mechanical advantage. Question number 24, state three differences between the three classes of levers. So here are the differences between the class 1, 2 and class 3 levers. You can write from here. Okay, so you can take the screenshot and you can complete your work in a neat and clean handwriting in your notebook. Question number 25, what is a pulley? A pulley is a flat circular disc with a groove in its edge and a rope passing through the groove. It is capable of rotating around a fixed point passing through its central axis called axle. Now, what is the mechanical advantage of an ideal pulley? In an ideal pulley, the effort applied is equal to the load to be lifted. That is, effort is equals to load, and mechanical advantage is equals to 1. Question number 27. The mechanical advantage of an actual pulley is less than 1. Give a reason. What is the justification for using the pulley then? So in an actual pulley, due to friction, the mechanical advantage is less than 1, and for the reason for using the pulley when its mechanical advantage is equals to 1 or less than 1 is that the pulley allows us to apply the effort downwards, that is in a convenient direction. Means to raise a load directly upward is difficult, but with the help of a pulley the effort can be applied in the downward direction, as I already explained to you today only in this video. That by using a pulley we can apply the effort in the downward direction, which is convenient for us. Therefore we use pulley even though its mechanical advantage is equals to 1 or less than 1. We can also hang on it and to make use of our own weight in order to apply the effort. Now, question number 28. Draw a neat label diagram showing a pulley being used to lift a load. How are load and effort related to an ideal situation? To raise a load, the load is attached to one end of the string and effort is applied on at the other end by pulling it in the downward direction, as you can see here in this figure. Okay, you have to draw this diagram also. Now, question number 29. What is an inclined plane and what is its use? Give two examples where it is used. So, an inclined plane is a rigid sloping surface over which heavy loads can be raised or lowered to a certain height or depth. The mechanical advantage of an inclined plane is a ratio of the length of the plank to the vertical height of the load raised. Now, its value is greater than 1, therefore, an inclined plane acts as a force multiplier. Thus, it can be used to lift heavy loads. Now, examples here you can see if a heavy box needs to be loaded on a lorry, it is far easier to push it over an inclined plane than to lift it up. Steeper the inclined plane, greater will be the effort required to push up the load. Sloping ramps, flyovers, roads on hills, and staircases are the examples of inclined plane. Now, question number 30. What is a screw? Give two examples. A screw is a simple machine which appears like an inclined plane wound around a rod with a pointed tip. Okay. So here, these are the examples. You can write any other examples also. And now question number 31. What is a wheel and axle? Give two examples. Of the wheel and axle is a simple machine having a wheel and an axle. The linear motion of axle is obtained by rotating the wheel so as to reduce friction. Example: steering wheel, screwdrivers, water tap, etc. Question number 32. How does a wheel help in moving the axle? Wheel and axle arrangement consists of two cylinders of different diameters joined together such that if one is made to rotate, the other also rotates. The axle is a cylindrical rod fixed to the center of a circular disc like object called the wheel. Okay, so this is answer number 32. How does a wheel help in moving the axle? Now, question number 33. What is a wedge? Give two examples. So, a wedge is a double inclined plane such that the two sloping surfaces taper to form either a sharp edge or a pointed edge. For example, knife, axe, and chisel. Okay, so you can write up to here. Now, question number 34. Name the machine to which the following belong: beam balance, lemon crusher, sugar tong. So, beam balance class 1 lever, lemon crusher class 2 lever, sugar tong class 3rd lever, ramp, an inclined plane, door and knob, doorknob, sorry, wheel and axle, needle, wedge. Question number 35. What care would you take to increase the lifespan of a machine which you use? So, here are some precautions that we can use to take care of our machine to increase the lifespan of the machine. Okay, so you can write from here. Now, question number 36. Select the correct answer. Select the correct statement. A wheelbarrow is a lever of class 1. The efficiency of a machine is always 100%. Friction in moving parts of a machine reduces its efficiency. No lever has a mechanical advantage greater than 1. It is easier to lift a load vertically up than to push it along an inclined plane. A screw is made by two inclined planes placed together. So the correct answer is friction in moving parts of a machine. It reduces its efficiency. Okay, so these are the question answers. Now the numericals. Question number 1 is in a machine, an effort of 10 kgf is applied to lift a load of 100 kgf. What is its mechanical advantage? So, mechanical advantage is load upon effort. Load given is 100 kgf and the effort is 10 kgf. Therefore, the mechanical advantage is 100 divided by 10, that is 10. Now, second question, the mechanical advantage of a machine is 5. How much load is it can exert for the effort of 2 kgf? So, mechanical advantage given is 5, effort is 2 kgf. So, mechanical advantage formula is load upon effort, and we have to find out load. Therefore, mechanical advantage multiplied by effort. So mechanical advantage is 5 and effort is 2, therefore the load is 10 kgf. Okay, now the question number third. Mechanical advantage of a machine is 2 and it is used to raise a load of 15 kgf. What effort is needed? So the mechanical advantage given here is 2 and load given is 15 kgf, and the formula for mechanical advantage is load upon effort. So from here we can find out the formula for effort. So by cross multiplying, effort is equals to load upon mechanical advantage, and load is 15 kgf and mechanical advantage is 2, therefore the effort is 7.5 kgf. Question number 4. A lever of length 100 centimeter has effort of 15 kgf at a distance of 40 centimeter from the fulcrum at one end. What load can be applied at its other end? So you can see here, effort arm is given to us and load arm is given to us 100 centimeter. Okay, and effort arm is 40 centimeter, and from formula for mechanical advantage in terms of effort arm and load arm is effort arm upon load arm, that is 40 upon 100 is equals to 0.4. Okay, and then you have to find what load can be applied at its other end. Therefore mechanical advantage we got from here 0.4. Now we also know that the mechanical advantage is equals to load upon effort. So mechanical advantage we have is 0.4 and effort given is 15 kgf. So from here we can find out the load, that is 15 multiplied by 0.4 is equals to 6 kgf. Now question number 5. In a lever, fulcrum is at one end at a distance of 30 centimeter from the load and effort is at the other end at a distance of 90 centimeter from the load. So from fulcrum is at 30 centimeter from the load. Okay, you can see here this is 30 centimeter from load is fulcrum is at the 30 centimeter from load, and also um, and effort is at the other end at a distance of 90 centimeter from the load, and from this distance from of effort from load is 90 centimeter, therefore effort arm will be 90 plus 30, because effort arm is the distance between the fulcrum and the effort. So the distance between this fulcrum and the load is 30 and effort and load is 90, therefore effort arm will be 90 plus 30, that is 120. Okay, so we have to find out the load arm. So load arm we have already found out from here the diagram, 30 centimeter, effort arm 120 centimeter. Now mechanical advantage formula is effort arm upon load arm. Therefore effort arm is 120 centimeter and load arm is 30 centimeter. Therefore mechanical advantage is equals to effort arm upon load arm, that is 120 divided by 30, that is 4. So these are the numericals of question number 4. By this our lesson number 4 is completed with all the question answers and numericals also. You have to complete this work in your notebook in a neat and clean handwriting, and also you have to learn all these answers. Okay, and you have to practice numericals so it will be clear to you. And next lesson we will start in our next video. Okay, thank you.